to you how that works. Not air, not oxygen, not hydrogen. It's just water. Doesn't water put fire out? Here's the problem. Water is not in a state. Water is the name of a compound. If I have one hydrogen and one oxygen and two hydrogens, and they're bound together, one molecule of this stuff, not a state of matter. It becomes a state when you have more than one. If you have a bunch all packed in really tight, you don't have room to draw it on your page. You might want to put it on the back maybe. If you have a bunch of these all packed in really tight, then it might be a solid. When you have a little bit more room in between them, where they can kind of slide around past each other, then you're probably looking at a liquid. When one of them gets enough energy that they can really, truly kind of break away from the one next to it, then it's a what? A gas. Gases have more energy than liquids. What's this hot plate doing? What's it doing to the energy? It's putting energy into the water. It's pumping it into the water. So all the little atoms of water here are getting more and more energy, and some of them are getting enough energy to spread apart from its neighbor like it's pushing it. And if it gets far enough away from its neighbor, it goes from a liquid to a gas. Even if the rest of it's completely surrounded by stuff that's still liquid. So these little bubbles, they're water. Right here above this steam, that's water as a gas. It's just that it's exactly the same molecule, they're just more spread out. All right. Going from a liquid to a gas. Energy in or energy out? Energy in. Endothermic or exothermic? Endothermic. Endothermic. All right. You need melting. Melting's on the test. You need vaporization, and it's two types of evaporation and boiling. They're on the test. I've done boiling. I better do evaporation. I'm using the analogy of students as for atoms. So you sitting in the room, you're the atoms of a solid with low energy. You walking the halls is like a liquid, moderate energy, able to flow past one another. Are you able to flow past one another when you're stuck in your seats in a classroom? No. Solid, liquid. Analogy seems to hold. A gas is dodgeball in the gym. Do you have more energy playing dodgeball than you do in the hallways? Yeah. Absolutely. All right. So a gas, they're whipping dodgeball at each other, dodging to get out of the way, the whole bit. So evaporation is you've got you're in the hallway, you're a liquid. You're walking past the gym where there's a dodgeball game going on. Somebody throws a ball out through the door and it hits you in the head. does your energy change?
Yeah.
Instantly. You get hit in a dodgeball, you get hit in the head with a dodgeball. When you're not playing, you're out in the hallway, your energy changes. Now, there's a couple of different things that might happen. You just might grab the ball and whip it back into the gym. You might be tempted to go into the gym and play some dodgeball. Or if you got hit hard enough, you might be tempted to go in and start a fight. Why do you do it? All right? But no matter what, you get hit in the head with a dodgeball, your energy goes up. Right? Well, if you've got a liquid like a glass of water, and then you've got a gas that's got high energy, those gas particles sometimes hit the liquid. And when they do, they give a little bit of energy to those particles that are liquid. And sometimes, one at a time, those liquid particles get enough energy to join the game of dodgeball. So they leave the liquid state and become the gas state. It can happen at the liquid itself can be at any temperature. But they get little bits of energy just from the bouncing around of the air in the room. And then finally they get just enough energy to break free, and then they become a gas. If you leave your glass of water out in the room long enough, eventually it will all break free and all turn into a gas. They'll all get hit by enough particles of air that they'll turn into a gas. Make sense? So that's what evaporation is. Now, evaporation only happens at the surface. How is evaporation different from boiling? Yeah.
Well, because it only happens on the surface and boiling goes like all throughout and affects it all. But
there's one other difference. That's correct. Evaporation is only at the surface. Boiling happens throughout. Evaporation can happen at any temperature. Boiling happens only at specific temperatures. Okay? Do you know that you can get any element, most compounds, and even some mixtures to go through all of these states? All of them? I can get aluminum to do this. I can get table salt to do this. I can get oxygen to do this. Yeah.
Could you get a rock to do it?
Yes.
That'd be cool.
Yes, I can. See, you've got a problem. You exist. Let's look at all temperature. The coldest temperature we have, the coldest temperature that we've been able to get to is about negative 273 degrees Celsius. That's it. That's the coldest temperature. All right? The temperature of the sun is 5,500 degrees Celsius. Your entire existence is between negative 80 degrees Celsius, coldest temperature on record, environmental temperature on Earth, and 59 degrees Celsius, hottest temperature recorded on Earth. It's like 130, 140 maybe. Okay? So your entire existence is just in this little window. Now it just so happens that water goes through all these stages in that window. You can get water as a solid, water as a liquid, and water as a gas in that window. Alright? But if I wanted sand, you were talking about rocks? Sand goes from a solid to a liquid at 1,700 degrees Celsius. That's when it melts. Is there still a long ways before the hottest temperature of the sun?
Yeah.
I can get it to boil too. I can get it turned into a gas. Is it something that we're likely to be touching? No, but it goes through all of these stages. What about oxygen? The stuff we're breathing. Oxygen boils. Where'd it go? I wrote it down. Oxygen boils at negative 183 degrees Celsius. I can get the air you breathe to turn into a liquid. I can get the air you breathe to turn into a solid. That happens at negative 218. Do you experience these things for yourself? Do you experience oxygen boiling and freezing? No. That temperature happens outside of your life, your normal life temperatures. Do you experience sand melting and boiling and turning into steam? No, because that happens at temperatures much higher than your everyday life. Your oven is probably the hottest temperature in your everyday life. It gets to 300 Celsius. Does that make sense? Yeah.
Wait, so when air turns to, like, freezes, what does it turn? Does it just turn into ice?
It turns into a solid, yeah.
Kind of scary.
Well, it has to be. This is a temperature way lower than your existence. Your existence is here. This is the coldest temperature on the planet, like, that exists in nature. These things happen in laboratories. Yeah.
But you can't turn those things into plasma?
What things?
Like sand or oxygen?
Why not?
I mean,
Of course you can. You have to get enough energy into them. But yeah. All right. So we know that if we add energy to a solid, it can turn it into a liquid. If we add energy to a liquid, it turns into a gas. If we want to add energy to a gas, what happens to it?
Turns into
Turns into a plasma.